Welcome, welcome, welcome. Thank you for coming. All right, everyone. Thank you. All right. Thank you guys. Thank you guys so much. Thank you for coming. Welcome to the Dr. Greg Show. December 2nd, 2025. Hope you guys are having a good day. Thank you for being here. Hope your day's going well. We had some good news in the realm of our organization. We are officially registered as a 501c3 and a 501c4, ladies and gentlemen. That is huge. That is huge. We are full a go for science and freedom for everyone. SAFE, which is going to be our umbrella 501c3 foundation. So it's going to be focused on education. And we're going to have a 501c4 for political action. So SAFE Foundation and SAFE Action Fund. The Action Fund is going to be able to get involved in politics, going to be able to get involved in elections, and the foundation will be about education. The 501c3, the 501c3 can be tax deducted. Yeah, that's the big benefit of the 501c3. So money donated there can be tax exempt. So that is nice. You can deduct money there. But both of them are nonprofit organizations. And yeah, it's big. It's a big thing. So basically what we do is we file a DBA, a doing business as, and in order to help. Are we Democrats? Yes, for sure. Yeah. We have to help the Democratic Party mobilize and be more reflective of our values and what we stand for. And I think that there's going to be a huge sea change in the Democratic Party coming up. A lot of people are going to be retiring. A lot of people are going to be on their way out. So we have an opportunity, in my opinion, in order to have a huge sway on the Democratic Party. Well, I mean, ousted or just natural causes. You know what I mean? You know what I mean, Renee? So, in all the best ways, they're retiring, and at some point, it has to happen. Yes, Tennessee news for today's election wasn't amazing, but unfortunately, I mean, the fight goes on, kind of thing. So, yeah, it's unfortunate, but it is what it is. We have some interesting news to talk about. Some wins. We like wins. We like talking about things that are helpful to us as a movement, right? We got to have some hopium. I think that it's really important to think about, hey, Ducre, it is exactly open mind. The GOP is very weak right now. They are failing to pass state legislative bills that they should be able to pass. The Maha agenda is failed spectacularly. Over the 423 bills that they tried to pass on the state level, hundreds and hundreds are failed, and that's why we are also piling on. So if you want to, please, guys, you can engage for science at action.drgregshow.com, and you can do some emails, do some phone calls, and make sure that the people in your state know that you are going to hold them accountable for attacking your public health. They're attacking you. They're attacking your children. They're attacking your parents. They're attacking your brothers and sisters. They are trying to create a world that has more disease in it, and we are trying to stop them. That's what we're trying to do. And we need to let them know that they failed, that their Maha agenda failed, and we will twist the knife as they squirm on the ground, and we will lord it over them. Absolutely. So please, action.drgregshow.com. If you haven't been there, guys, you should just check it out for sure. You know, hey, Socio Mike. Yes, dude. Yeah, of course, man. Yeah, we do. We love vaccines here. We love people who get vaccinated. We appreciate vaccinated people. Thank you for getting vaccinated. We love vaccinated people. All right, guys. We got a good old-fashioned vaccine party, ladies and gentlemen. You got an HPV vaccination. Good job. Socio Mike. Good job. 11:56, ladies and gentlemen, in 3, 2, 1. Good job, man. Good job. Hey, Helen, thank you for coming. You went dark there for a minute. Uh-oh. Yeah, Tyler. Yeah, it is. I mean, we have to think about what we're fighting up against, man. These diseases hurt people. You know? Guys, we are anti-disease, anti-virus, right? We have to know what we're fighting against. And at the end of the day, we're not trying to fight Republicans on this, right? We're not trying. The big bad enemy isn't the Republican Party. It's viruses. It's the disease that they cause. We would love to have Republicans join us like they have previously to get vaccinated again so that their children can enjoy the fruits of a society that isn't riddled with diseases and communicable diseases. We are begging the Republican Party to come back to reality on this. We are not anti-GOP, right? We are not anti-Republican Party. We're anti-disease and viruses. But if they stand with the viruses, if they stand with the disease, then we have to oppose them, right? That is the message. So please do not stand on the team of viruses against humans. Do not stand on the side of viruses and disease against us. I sent 4 emails today. Now to the beginning of the alphabet. Oh, nice, Helen. Absolutely. Incredible. 827, guys. 827 political actions. Guys, that's emails and calls that we've done in order to stop the Maha agenda. In 3, 2, 1. What am I talking about? Just stay around and you'll understand. Yeah, Genghis. I mean, and viruses have been around, but we have created tools in order to help eradicate them. And those tools, those preventative medicines, are vaccines. Science has given that to us, so we should use them. Absolutely. I'm happy to talk to you guys if you want in voice about it. If you want to request up, absolutely. But that's just what the reality is. So thank you guys for getting vaccinated. Thank you for going to action.drgregshow.com. Thanks for doing some emails. Thanks for doing some phone calls, because that's what's important, guys. We have to help us defeat the Make America Diseased Again agenda by RFK. That's the biggest thing. All right, guys. Big thing. That's honestly a good idea. 1 second, I'm going to write that down. Let's see. People keep thinking humans are in control of our destiny. I mean, I definitely think that there's a huge component in medicine in order to help us understand stuff, for sure. You know, understand and prevent diseases. I mean, that's kind of the whole point. So that's definitely, I mean, we've gone from disease causing 50% of child mortality down to 0.02%. So that specifically is modern medicine, antibiotics, vaccines. These have all done it. Absolutely. So. Okay. So here it is in a graph form. How I'd run that data. Well, here's the data. Here it is. So again, yeah, we like data here. It's okay. So you see how for the longest time here. So see how we're at 48%, Rome 50%, Nazca Peru 48%, 400 Spain 45%. 48% is the child mortality across 21 historical societies that we have. Okay, Peru 53%, Japan 1300s to 1400s 48%, Japan in 1700s 51%. So this is the amount of children that are dying. 50%. So I have 4 kids. I'd be lucky to have 2. All right. And then what happens? Where's the line going? It stops here, and it goes down. Global mortality rate in 1950, 27%. Somalia has the highest mortality rate in the world right now, but mortality rate in 2020, 4.3%. And then it goes down even further. The global mortality rate in 2020, 4.3 in Iceland, Finland, and Norway, 0.3%. So guess what? That mortality rate dropping from the 1850s is from... I can't hear you. Yeah, vaccines, modern medicine, science. Exactly, Pink. Yes, exactly. That's what did it. Okay? Hey Ness, how's it going? There's a new TikTok update. Okay, I don't know what that is. I don't know what that means. But thank you. All right, guys. Okay. So, in accordance with that, we celebrate wins here. I need to get my COVID-19 shot. Yeah, Pink. Yeah, for sure, man. It helps you with it helps you to help prevent long COVID. It also helps you with cancer. There's been anti-cancer properties that have been seen with the mRNA lipid nanoparticle vaccine specifically. And in addition, it actually helps your body fight existing and prevent infections. Very good. Very good stuff. So this is Illinois. Oh yeah, and by the way, Pink, get your flu shot too. It's a bad one this year. Flu shot is very important to get this year. The flu is very bad. Oh, wow. Oh, Tyler, that's really nice of you. Thank you. Thank you. I love Professor Dave. Thank you. Thank you for saying that. Nice, Pink. Good job, dude. Pink, can we celebrate you? Thank you for getting your vaccine, dude. We celebrate people who get vaccinated here, so we'll celebrate you, Pink. Pink Nicky, guys. Guys, I think this is his first vaccine party here. Let's give it 11:57. Let's give it to him, guys. Pink Nicky, let's give it up. We do V's in chat for vaccine or MAVA, which is Make America Vaccinated Again. In 3, 2, 1. Good job, Pink Nicky. Good job, man. Appreciate you. Good work. All right. Today, Governor J.B. Pritzker joined the state Illinois bill sponsor and public health experts to sign HB 767. The legislation expands and codifies Governor Pritzker's executive order of 2025-04, which empowers the Illinois Department of Health to offer transparent, science-based vaccine guidelines through its expert immunization advisory board. They're creating their own version of the HHS panel that RFK took over. Isn't that incredible? They're creating their own immunization advisory board while also expanding vaccine access. While RFK Jr. and his QAnon-inspired colleagues spread conspiracy theories and dangerous misinformation about the vaccines, Illinois is stepping up to protect the health of our people, says Governor J.B. Pritzker. It is vitally important that Illinois families can get trusted advice about vaccines, guided by experts in established research. With this new law, we will be able to respond swiftly to any dangerous or anti-science action at the federal level and ensure Illinoisians stay protected. More affordable and accessible health care for all Illinoisians prevents illness and saves lives. Bravo, Illinois. Bravo. This is the type of leadership that we need. We need this to be state by state. Every single state needs to be passing this stuff right now. Absolutely. We need to codify these types of actions into law immediately. So HB 767 ensures Illinoisians will receive clear science-based immunization guidelines as federal recommendations grow more contradictory and confusing. While the federal government abandons its critical role in public health leadership, the Pritzker administration is stepping up to protect health and well-being. Incredible. Here are the provisions, guys. This is amazing. Illinoisans. Is that right? Illinoisans? That's Illinoisans. Okay. All right, Renee. We'll have to trust you. Are you? I don't think so. I think you're setting me up on that one. I think you're trying to clip me. I don't know. I don't trust you at all. I'm very scared. This is it. This is how we get shut down, guys. Illinoisans. 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 Okay, Christina. See? Christina, there you go. You're to the top. Thank you. All right, Renee. All right, we're gonna get shut down. We're gonna get canceled for sure. Illinoisan. Oh, Illinoisan. Okay. Yes, Skog. That's the type of jokes that we love here. They're taking the ill out of Illinois. That's amazing. That is amazing. There you go, Skog. Incredible. Absolutely incredible. There you go, Skog. That you're amazing. You're a mod now. That's the type of content that we need here, okay? That's the type of that's what you need. Thank you, Skog. Thank you, Skog. All right. Key provisions of HB 767. Create and publish vaccine guidelines for Illinoisans. IDPH will create and publish vaccine guidelines for Illinoisans based on experts from the Illinois Immunization Advisory Committee. Previously, Illinois and other states relied on the federal government through the ACIP for this resource. They got taken over. And Illinois is like, wait, we have a power to actually have our own science. We have amazing scientists here. We can just trust them. Codifies the structure of the IAC, including checks and balances. The bill specifies the membership and functions of the IAC and out of commitment to ensuring all recommendations are rooted in science. Provides a mechanism for the committee to override director recommendations. That's incredible, guys. So they're going to do rooted in science. They're going to do non-vibes vaccine science, guys. That's incredible. Hey, Hazel. Welcome. Welcome back. Require insurance companies to cover vaccines by recommended by IDPH. This is a huge one, guys. They're actually going to help pay for the vaccines. Thank you, Linda. The state-regulated health insurance issuers are required to cover vaccines and related administration based on IDPH recommendations, even if they extend beyond the ACIP schedules. That's huge, guys. That means that the recommendation of the CDC revokes, meaning that the healthcare insurance companies are like, it's not recommended. Why would I want to do that? Now they're required, guys. That's amazing. They expand youth vaccine access in pharmacies. Reduce the minimum age from 7 to 3 for pharmacist administration of certain vaccines, making them more accessible. Exactly, guys. Very important. They're safe, and we can administer them at the pharmacies instead of having to go to the PCP, which means that we can expand access to life-saving vaccines. Incredible work, Illinois. Incredible work. Those are the wins that we have to celebrate. We have to push up. That is incredible. Here's from the IDPH director, Dr. Samir Vorha. Today is more than a bill signing. It is a reaffirmation of Illinois' commitment to science, trust, and improving the health of every family in our state. This new law represents Illinois at its best, leading with evidence, protecting with purpose, and preparing for the future. By strengthening immunization guidance and expanding access to vaccines, HB 767 ensures that families across Illinois have the tools they need to stay healthy and safe. Incredible. Huge win. Huge win. Exactly, Open Sets. Genuinely, I really want to see way more states do this. I think that this could be like a really interesting... So SAFE, the idea of SAFE is our 501c4, guys. We have an official 501c4 that we have founded for the first time ever in the history of the internet, of recorded history, ladies and gentlemen. We have a 501c4 that we made, like with no, it's just us. You know what I mean? It's funded by us. It is created by us, and it is going to make impacts in the world. But we're going to start in the United States, obviously. But I think it could have a huge impact. I genuinely do. And I think that this type of model, creating and mobilizing these streamer communities, these type of online communities into action by 501c4, by official nonprofits, because it forces me to disclose things, right? It forces disclosure, transparency, honesty to you. And it's not just a donor drive, right? A donor drive is how people normally did this, where they would ask for money for some cause. But now, through the 501c4, our community has action. We together have a route forward that we can help change things. And I think that this is going to be a stepping stone, and I genuinely do think that this is going to be something that people mirror all across all the streaming platforms. I think that it's cool, that it's amazing. I'm so proud that we started it here, but I think it's going to catch on, and MAVA is going to be huge. I genuinely do think that. And part of that is to actually recommend legislation that we can get passed, right? We want to take and mirror past legislation that can actually get passed at the state level, get passed at the city hall level, and actually propose these things. And hey, Brian F., how's it going, man? And I think we can do that through SAFE. Brian, we're talking about how our 501c3 and our 501c4 are official now. We are officially a nonprofit. We have an education-based 501c3 that's tax exempt, that you can write off. And we have a 501c4 that's our action fund that can get involved more with politics and the elections more. And I'm talking about how proud and unique it is to have that we have that as a community going forward. So thank you, Lo. Thank you, Brian. You guys are. I agree, Hazel. I think it's so cool, and I think that it's something that's so unique. I'm very, very proud. Thank you, Amy. Hey, Marissa, how's it going? I'm happy that you're here too. It's a good day. It's a good day for MAVA and SAFE, which is Science and Freedom for Everyone. That is the large nonprofit that we have. Science and freedom, that's something that we really strive for, right? That is, you're creating through science, you are creating freedom. Through preventable health measures, you are public health, we are creating freedom for everyone. That's what we all talk about, right? We all talk about compassion and making the world better for everyone. Oh, okay. Oh, it's, hey, ex-cult girl, what's up? Perfect. Well, thank you for saying that. I wouldn't have been able to tell because of your profile picture. Lo, let's go. That's amazing. 5 emails by Lo, guys. 8:32. Let's give it up for Lo. 3, 2, 1. Lo, good job. Formerly chatter, previously known as X-Cult Girl. Thank you so much. It feels more and more like people are becoming more active and aware. Exactly, Brian. For sure. I think that people are getting engaged, especially going into the midterms. The next 6 months, the next year, guys, is going to be all trails blazing forward. We want MAVA to be a huge part of the next election. They have to, every single candidate must take our pledge in order to be seen as a legitimate political appointment. Every representative, if they are going to represent people, they need to say yes to our pledge and support vaccines, vaccine science, vaccine access. Absolutely. Come to my march. Well, it matters where it is, Pink, but maybe. I don't know. This year is going to be the one. I think so, Brian. I think so. I think it's going to be way bigger. I think we're just getting started, and I think that I think it's going to be amazing, dude. I think it's going to be a really good year. All right. So that's that. Child infant mortality. I didn't see any huge science news. Oh, that's cool. Interesting. I didn't see this. We just did the ITER, guys. This is so cool. We know this. We actually remember we watched this whole thing come. What? 1 second. Let me log on here. So annoying. You silly science mag. Log in. That's so cool that they actually have a an ITER one the day after we deep dove it. Guys, I've actually put up, if you're interested in just the nuclear portion, we dove deep into nuclear reactors and nuclear technology last night. So if you didn't watch that, I actually released it as its own video on my YouTube, drgregshow.com. YouTube archive is there, guys. Honestly, it was so incredible going into fusion. Fission is current technology. Fusion is what we were trying to, the moonshot that we were trying to go to. And yeah, really cool. Exactly, Hazel. So this is cool. There's a science story that we can read here real quick. So that's what this is. That's what ITER is. We know that now. Isn't that so cool? Yeah, Lo. Definitely check out the YouTube archives if you haven't. It's a really good. And we had an engineer that came in and actually helped us through and told us what was actually happening. So it was an expert panel that was actually happening. Oh, thanks, Pink. Reorganization could shift mission of the U.S. state's largest funder of the physical sciences. So as Energy Department prioritizes AI and fusion, basic research faces squeeze. The DOE is reorganizing its scientific efforts by establishing new office or types of research based on the White House. A 2-paragraph press release and revised organizational chart issued on 20 November announced the launch of an Office of Fusion and an Office of Artificial Intelligence and Quantum. So I don't know if this is going to be in here, but I have a friend that works for the Department of Energy, and they actually talked about, so one of the labs, the national labs, was renewable. Actually it was the Office of Renewable Labs or something, renewable energy. Well, renewable is a banned word now, so they're actually changing it. Because it's in Colorado, they're calling it the Rockies Lab now. So the absolute paper thin tiger of these guys and how vulnerable they are and how weak they are on just the names of things. It just makes me laugh so much that these guys think that they are so strong and masculine, but they can't have renewable in a department name. It's good. Hi, aloha. The DOE provided no further details, but the move worries scientists. The new offices could be formed by carving pieces out of the DOE's storied Office of Science, and the United States' largest funder of the physical science and its builder of big facilities from X-ray sources to atom smashers. Observers say that the change suggests the Office of Science, which has an $8.2 billion annual budget and funds everything from biofuels to particle physics, could shrink and effectively becomes DOE's Office of Misfit Research. We can't abandon the rest of science, warns one longtime DOE observer who requested anonymity. See, this is another thing, guys. They request anonymity and they have to leak this stuff in order, because there's going to be retaliations just for speaking out. On November 24th, Trump underscored his administration's emphasis on AI by signaling an executive order to launch the Genesis mission, a national effort to unleash a new age of AI-accelerated innovation and discovery that can solve the most challenging problems of the century. Genesis will be led by DOE Undersecretary of Science Dario Gil. In a 4-page open letter to DOE research community, Gil, a computer scientist, calls for a, quote, integrated science and security platform connecting the world's best supercomputers, AIs, and next-generation quantum computers to the most exquisite scientific instruments in the nation to create the most complex and powerful scientific instruments ever built. Man, is that fluffy language. Crazy. Gil's letter doesn't mention the reorganization, and at press time, the DOE did not respond to emailed questions, but the new AI quantum office is sure to play a prominent role. Fusion researchers have long clamored for DOE to form a separate Office of Fusion by extricating the $790 million in fusion energy sciences program from the Office of Science. Communities want to see their program reporting as high up in the department as possible, if not to an undersecretary or the secretary if possible. It says James Decker, a former deputy director of the Office of Science. Fusion fits in the Office of Science's basic research mission poorly. Decker adds, I always considered it an applied program. Here we go. We're talking about fusion now. Here we go, guys. The need for the fusion office has grown when the emergence of multiple private companies aiming to achieve fusion power in a few years, says Martin Greenwald, a physicist at the MIT and co-founder of the Commonwealth Fusion Systems. Still, the new office will answer to Gil and not to the Undersecretary of Energy, protecting it a little bit from the pressures to produce immediate commercial results. And then it goes on and talks about more of the reorganization and the history of it. But private companies, this is very weird. I didn't think that private companies could be profitable so far with fusion when they're just starting to get this up. That means that they would have to be turning a profit within years, right? Private companies aim to demonstrate working fusion reactors in 2025. Did they? Have they? Startups are optimistic about the achieving energy break-even, though government scientists remain skeptical. Well, it doesn't seem like they did that because we don't know about it yet. It's already happening, one of the startups, in the next year or two. Interesting. General Fusion. Oh, it's in Canada. Interesting. This year, the company will assemble its machine 32 magnets. Our current schedule, we're going to begin operations in 2026 and get net energy in 2027. Wow, that's still like a year operating with no profit. 2026 or 2027. That's a lot of money going into that for pretty long. That's pretty long. Okay, guys. Awesome. All right. I also had something kind of funny. I thought I saw this. We had our North Korean style fluff piece from our government today, where pretty much nobody critically engages with Trump at all and falls over one another in order to try and show fealty to this man. Yeah, groveling, exactly, Helen. It's just disgusting how these people have no spine, how they have no self-respect, and they can't help themselves because they know that this is what their career has come to, right? This is what is required for them to keep their jobs in order to make whatever concessions they need to do in order to do this nonsense. And just check how disgusting this is. So this is DHS Secretary Kristi Noem to Trump.
And worked hard doing security, and they have been absolutely fantastic. Sir, you made it through hurricane season without a hurricane. Yeah. And so FEMA, you kept the hurricanes away. So we appreciate that. And FEMA is deploying resources and dollars 150% faster than ever before. So somebody does have something bad that happens to them, you are immediately there helping them and telling them they have the resources to get back up on their feet and work.
Did you catch that? She said, you kept the hurricanes away. Let's listen again. Seriously, she said, you kept the hurricanes away.
They have been absolutely fantastic. Sir, you made it through hurricane season without a hurricane. Yeah. And so FEMA, you kept the hurricanes away. So we appreciate.
See how they're laughing? See how it's like a nervous laughter? See how it's nervous laughter? No, exactly, you fired. You're exactly right. I am so happy that you said that because that's exactly my point. They are putting it off like it's a joke, and they are laughing like it's a joke, but this isn't a joke for them. One of the things that was so ridiculous to me growing up was the North Korean stories of their dear leaders where they could just do supernatural things, right? The dear leader, his first time playing golf, got 15 holes in one, in a row. And you're like, what kind of person, in what world would anyone actually get that or understand that as being truthful? And what's important to know in these scenarios is that this is a test. These are the test scenarios that they are floating this stuff. They are absolutely floating this stuff and saying, believe this stuff or you're out of the group. They're saying, that's why they're laughing, because they're laughing to encourage this behavior, right? So anyone that said, what? That's so stupid, you're out. It's a lie that's so absurd, and they're absolutely not joking. It's not a joke. Because all of those people in that meeting, if they are asked about that, would say he absolutely kept the hurricanes away with his monitoring, with his the NOAA stuff, the whatever he did. Trump absolutely deserves credit for this. And it just blows my mind. It just blows my mind that and look how it mirrors this whole thing with Trump 2028 too, right? It's all about something that's so ridiculous, and when he comes out, they always do the nervous laughter. And then guess what? It's not a joke when it comes out again. So again, I'm telling you, watch for the next couple of weeks. I wonder if this will be brought up again, and we'll see if someone actually references this and says that Trump actually kept the hurricanes away. I wouldn't be surprised. I'm just saying it mirrors the same type of psychosis that we see in North Korea and their supernatural cult-like figures, their demagogues of their leaders, and of the way that the Trump administration puts these checkpoints of these absurd lies out that require you to buy in or you are castigated out. Just like how they laughed, right? They laughed when Trump 2028 came out. Thanks, MT. And then now it's not so much of a joke, huh? Now they're saying he has to become a third term president. He has to become a third term. There is no joke about that. It's not a joke anymore. It's he has to become a third term president. I'm telling you, just watch. I'd love to be wrong in these scenarios. In these, I would love to be wrong. And Fired My Doc, I would love to be wrong, and I would love to sit up here, and you could have, stitch this into some highlight reel about how absurd I am. I would love that. I genuinely would love that. But it's not going to happen, I don't think. Exactly, Snowy River. It's normalization. Exactly. So, it's bad. It's bad. All right, guys. So, I was thinking we are on our environmental week. We are learning about the environment, the ways that the humans are impacting the environment. Oh, actually, wait. Sorry. I totally just forgot. I remembered now what I was supposed to do because I was like, wait, what's going on? I have a debate on Thursday. I am infiltrating red pill spaces, ladies and gentlemen. They are not safe. We are bursting their bubbles. We are going into their world. And one of them, this is one, by the way. These guys don't want to debate vaccines. They don't want to debate vaccines. So while Maha is trying to rip away all of our public health, they don't want to actually talk about it, and they don't want to debate it. So anyway, but thank you for the opportunity. Thank you for inviting me on. I appreciate you. So, but it's about human gene editing. So, what debate? Oh, who, what, when? It's the Raging Tomato. It's a right-wing red pill space, and they want to do gene editing. So we're gonna be talking about CRISPR gene editing, 6 p.m. Pacific time. Let me make you 100% sure. It's not on Rumble. It's gonna be here on TikTok. Yeah, 6 o'clock Pacific time on Thursday. So I need to do some research on. I need to do some research on human gene editing. With David R. Liu, my friend, David R. Liu. Yes. All right, guys. Well, okay. Well, we are talking about human editing. So you better know that we are talking about David R. Liu, ladies and gentlemen. If there's one scientist that you've got to know, David R. Liu. I don't know what's wrong. Thank you, Linda. Right, Bart official GT. Okay, cool. Bear Bart. Okay, yeah, I'd love to. Ladies and gentlemen, please, David R. Liu is one of the best scientists in the world. Bear bait. Okay. I don't know who Bear Bait is. Bear Bait. Who is Bear Bait? Bear Bait. TikTok. Oh, okay. Oh, wow. Oh, cool. Cool. Yeah. I'll follow them and see what's up. Okay, sweet. Yeah, I just followed them, so yeah, I'm curious about what they're saying. Guys, David R. Liu is one of the best scientists in the world, okay? Most scientists are lucky to have one breakthrough, one thing, one contribution that they have made to science as a whole that really phase changes, that makes everything different. But David R. Liu has multiple. That's the crazy thing. The Nobel Prize that that David R. Liu gets, and he will get the Nobel Prize. The problem with the Nobel Prize committee will be, what breakthrough does he actually get the Nobel Prize for? Because he has, in his short career, done so many amazing things, so many breakthroughs. He's basically one of the best molecular biologists that's ever existed, and he just happened to be living during the time that CRISPR was invented. So this guy has the best tools, the best knowledge. He didn't even do a postdoc. He went straight from PhD, graduated PhD at Harvard, became a Harvard professor the next year. I mean, I can't tell you how crazy that is with how young he is in the early 2000s. He probably is one of the last professors to ever do that, because normally you're doing a 2, 4, 6, 8 year postdoc in order to get a professor slot anywhere in the world. And he got it to Harvard. So he is an absolute genius. So I love David R. Liu, guys. That would be like one of my, I went to a seminar with him, and like asked him a question and stuff. He's a human being. He is very nice. He's very cool. He isn't, he's very like human, and sometimes, hey guys, you know what I mean? Sometimes scientists get a little weird, you know what I mean? Sometimes scientists are kind of hard to be personable. Oh yeah, I'm a huge fan of him. I'm a huge fan of David R. Liu and Frances Arnold, to be honest with you too. Frances Arnold is the other scientist that I absolutely adore. She does unbelievable work. But let's watch what he has to say. So let's see. So it's 6 months ago. 6 years ago, and that TED Talk is a little far away. He's done a lot since then, basically. So let's just look at this.
So every one of your cells has about 6 billion letters of DNA, A, C, G, and T. Your genome, which is the sum of these 6 billion letters, is not perfectly stable. Mistakes can be made while in development as an embryo. Mistakes can be made when your cells replicate as you grow or as you heal injury. If you smoke, get exposed to sunlight, eat certain kinds of foods, some of those mistakes can lead to diseases if they're not corrected. My name is David Liu. I'm a professor at Broad Institute, Harvard University, and HHMI. There are 60 million children that will die before they reach their 5th birthday because of their genetic disease. These genetic diseases include thousands.
Yeah, Carpentier is amazing too. Yeah, Doudna is amazing. That's like, I mean, I could fan a lot of people, but yeah, absolutely. Doudna is incredible for the steadfast fight to study defense mechanisms of bacteria for so long, and it's just incredible, it boggles the mind, like why she was just so steadfast for so long trying to study that stuff. In the late 90s, just had it really going for it. It wasn't a big area of research. She just kept going for it. And Carpentier and her, they just had this idea about these pieces of genomes that they found, and they found it repeating, and they didn't understand why. And then the seminal paper in 2008 was when they actually made the discovery of clustered regularly interspaced short polydromic repeats, which they made understandable, like what those repeated regions of the genome were. And it's basically the hit list for the attack dog that they wanted to see. Yeah, it is. It is OpenSets. I agree. So really healing people's gene sequences, fixing them. Yeah, Pink. So not all, hey Manny, not all, hey Bilbo, what's up, man? Not all mutations are similar. Not all mutations are the same, and some of them are very, very bad. So some of them are basically single point mutations that have a huge impact on the genomes, and that's a huge thing. And basically, David R. Liu, through, it's called prime editing. So prime editing is basically taking individual nucleotides and changing them from one to the other. There's lots of different ways that Cas9, which is basically the scissors, he basically changed the scissors into a pencil, and he just erases one and then draws in another nucleotide, and that allowed new sequences to be fixed. Are mental illnesses from bad gene sequences? Usually those are so the brain is very complex so to have single point mutations confined, something like that. I don't know of any offhand, but we're talking about like PKU disease or something like that, where it's like just a single point mutation could render someone's quality of life significantly bad. But honestly, this is a good finding for me, and probably one of the reasons why I'm doing this research, trying to understand exactly that question, Pink.
Of different diseases. You've heard of them: cystic fibrosis, Tay-Sachs disease, sickle cell disease, Rett syndrome, progeria, spinal muscular atrophy, and on and on. There are no treatments that actually fix the root cause of the disease, the misspelling in the patient's DNA. A hallmark of chemistry is using our ability to change the structure of a molecule in order to impart new functions on that molecule. The molecule that our lab was most interested in treating, like the subject of a chemistry problem, was DNA. That eventually led to the creation of some of the gene editing tools like base editors and prime editors. Base editing and prime editing allow us to change DNA sequences of our choosing into sequences that we believe will offer some therapeutic benefit to patients. Base editors are sort of like DNA pencils. They rewrite an individual.
I did not know that he was going to use pencils there. That's hilarious. That is very funny. So that's nice. I agree. They're like pencils. That's really funny. That's a great analogy, David R. Liu. That's a great. I agree.
Individual DNA letter, inverting it by actually rearranging the atoms on the DNA base. Base editing builds on CRISPR-Cas9 to cut DNA sequences. But unfortunately, for most genetic diseases, the problem that causes the disease is that the gene is already messed up somehow, and we need to fix it rather than further disable it. The idea behind base editing began in late 2013 with Alexis Comore. We first had to determine if we could recruit programmable DNA binding proteins like CRISPR-Cas9 that perform chemistry on DNA and not unwanted changes elsewhere.
So that's called off-target mutations. So basically, you have a guide RNA sequence or a CRISPR RNA sequence that is 20 base pairs long, and it searches the entire genome looking for that piece of that sequence. And 20 base pairs you would think is pretty unique, but it's actually kind of like, you can be one base pair off in the center or something, or on the end, and it might be okay. And then there's a second, like a lock and key, kind of a second point where it's a PAM editor. So it's like a double check, So one of the big things when CRISPR came out was basically off-target cutting or off-target effects of CRISPR-Cas9. So the idea is that we need to make CRISPR more precise and no off targets, because if you're going to edit a cell, you could have that off target be a critical protein, right? And now you've knocked out a critical protein, so what happens to that cell? It dies. Well, that's not good, So the idea is you want to have, as precise as possible and no deleterious or off target mutations as well.
And once we did that, we ended up with sort of a mess. We got a machine that could change one base to another base, but it did so not cleanly at all. It was more like a base randomizer, not a base editor. It also worked very inefficiently. We thought about the problem and realized that our own cell's DNA repair machinery was making a mess of the target site that we were trying to edit. So we added this extra protein that protected the base edit from being tinkered with by our cell's DNA repair protein. The base edits in that second generation became much cleaner.
There's a guide RNA, so that guide RNA is finding that, and then they're binding, the Cas9's binding.
And much more efficient. And then finally, in sort of the third stage, increasing the efficiency of the editing. DNA have two strands. When we made the first base editor, we disabled its ability to cut both DNA strands. What we should do is restore the ability to cut just one DNA strand. If you nick the unedited strand, that tricks the cells into remaking that part of the unedited strand, using the edited strand as a template.
Oh, that's genius. That's great. I didn't realize that. That's really good. That's incredible.
Which then makes the edit permanent, because now both DNA strands have the edited information in it. And now pretty much all base editors use this approach. Prime editors are another kind of engineered molecular machine, but instead of performing chemistry on an individual DNA base, a prime editor acts as a sort of DNA word processor that can perform true search and replace genome editing. Prime editors are even more complicated molecular machines than base editors. Andrew Anzalone, who led the development of prime editing, broke down the problem into a series of 4 challenges that we glibly nicknamed the 4 small miracles. The first of those challenges was showing that a sequence in the guide RNA could actually be copied into a target DNA sequence. So that was sort of challenge number 1. But the cell is a very different place compared to a test tube. To address the second challenge, Andrew used yeast cells. But that was really still the early stages of prime editing. And so the third challenge was figure out how to get prime editing to work in a human cell. And that's where we encountered our first incredibly discouraging result, because when Andrew took the same system that worked so beautifully in yeast cells and tried to perform the first prime edit in human cells, he got 0 editing. When you get 0% of the result that you want, it's very hard to know if your assumptions are flawed. We made a big list of all of the possible reasons why prime editing might have failed in human cells. And it was a sobering list because some of those explanations were not fixable by us. But fortunately, the problem turned out to be an aspect that we could fix. The length of the runway of DNA that you need in order to prime the DNA copying event. This is actually why prime editing is called prime editing. That requires a short DNA runway.
The PAM sequence. There you go. So that's like that little double checker thing. That's the part.
Serve as sort of a landing strip for a new piece of DNA to begin copying the new edited DNA sequence. And that priming process is different in human cells compared to yeast cells. The
no
runway
way.
needed to be a little bit longer. Not too long, not too short. It had to be just the right Goldilocks length. When he reached that Goldilocks length, we observed the very first prime editing in human cells.
What was it? I'm confused.
Too short. It had to be just the right Goldilocks length. When he reached that Goldilocks length,
there's a space between the PAM site and the cut of the indel. It's like two base pairs. I wonder if that's what they're talking about. 2 base pairs difference. I wonder if they're changing that or if they're using a different region. That's interesting. Wow, I gotta read this paper.
we observed the very first prime editing in human cells. But it was not efficient. And so in the fourth challenge, we introduced specific changes to the prime editor protein that increased its efficiency enormously. And we also used the same trick that Alexis developed of nicking the non-edited DNA strand. And the combination of those improvements resulted in the first efficient prime editing in living human cells. And since then, prime editors have been used by literally thousands of laboratories around the world. And recently, the very first prime editing clinical trial has begun. One of the really exciting implications of the versatility of prime editing, we can replace just about any DNA sequence in a human cell and perhaps in a patient with just about any DNA sequence of our choosing. That flexibility opens up an enormous number of possibilities beyond simply fixing a mutation that causes a specific disease. One direction that our lab is vigorously pursuing now that takes more creative advantage of this flexibility is to perform prime editing in ways that allow a single prime editor to treat not just one mutation.
Yeah, guys, he talked about this. He teased it that they're figuring out a way to change. So right now it has to be very specific to your genome, to your disease, that kind of stuff. He's basically teasing that there is a way, and he's going to release it in early 2026, the way that they think that they've found to actually have one, prime editor for multiple diseases, which is amazing. The idea that you could have one prime editor that could have dozens of different disease that you could cure. It's unbelievable. So they're not just having to start brand new at each step. This is something that they could use for multiple. It's wow.
Mutation that causes one disease, or even 10 mutations that cause one disease, but perhaps hundreds of mutations or thousands of mutations that cause many different diseases with one drug, one composition of matter, one prime editor, one guide RNA, what we call disease agnostic therapeutic genome editing. Hopefully we'll report
disease agnostic genome editing. DAGE, D-A-G-E. That'd be incredible. It's a miracle. Hazel, don't you dare. It's not a miracle. It's science, and it needs to be funded. It doesn't exist in hopes and prayers. It exists because of public funds, and David Liu can do his thing because of public and science and what we can achieve together through actually funding these things for long periods of time. So it's exactly, Linda, they're not cheap. So we're going to look into that prime editing human trial right now.
Our first example of doing so later this year.
Exactly. See, there you go. See, you just teased it. Oh my gosh, how crazy. Okay, Hazel. Sure. All right. Okay, so prime editing human trial. First ever prime editing therapy shows safety. Shows safety and efficacy in patient with chronic granulomatous disease. CGD is caused by a genetic mutation in one of 5 genes that are essential for the white blood cell enzyme. Chronic granulomatous disease is a rare inherited immune disorder that prevents certain white blood cells from properly killing bacteria and fungi. Oh, that's not good. You don't want that. Okay, can't read that. Press release. Prime Medicine. Is there any other press releases? This is from May. May. They're doing cystic fibrosis research. Here we go. Breakthrough in clinical data. All right. Clinical data shared by Prime Medicine earlier this week provides the first indication that prime editing is safe and efficacious in humans. These data was collected from the first patient dose in the first ever clinical trial of the prime editing therapeutic. Specifically, the phase 1-2 multinational trial is evaluating the safety, biological activity, and preliminary efficacy of PM359 in adults and children with chronic granulomatous disease. This rare inherited immune deficiency is characterized by increased susceptibility to bacterial, mycobacterial, and fungal infections. Symptoms typically begin in early childhood. CGD arises through mutations in any of the genes that encode the subunits of the NADPH oxidase complex, which is indispensable for phagocytosis of pathogens, particularly in neutrophils. Mutations typically occur in the following genes: 1, 2, 3, 4, 5, 6 genes. There's 5 different types. So the different genetic mutations have different variants. PM359 is an autologous ex vivo hematopoietic stem cell therapy that is prime edited to correct the del-GT mutation in the NCF1 gene. This is the most prevalent disease-causing mutation in the P47 variant of CGD, which is expected to affect approximately 25% of all CGD cases. So it can't even do all of them. Hey, Jorge Physics, what's up, man? I have a human gene editing debate on Thursday, so we are doing research on that. We're trying to learn as much about it. Gene editing could be creating a bioweapon that targets DNA. I mean, CRISPR isn't the first one, gene editing tool that we have, so it's not like this would be a new technology that if they wanted to do that, they could have already done that, basically. Could CRISPR be used in order to create, a bioweapon? Like, absolutely, for sure. Just like how, like, a hammer could be used in order to create something that would be go kabloomy, So it's just a tool kind of thing. Yeah. I don't think it's dangerous. There are safeguards in place. Basically, in order to synthesize DNA, you have to run it through checks, and they make sure that you're not making anything that is, resembling a weapon. So they have checks that way. Yeah, exactly, Sandy. Yeah, they defunded a lot of this research. The David Liu stuff would definitely be delivered by mRNA and lipid nanoparticles. So it's pretty crazy that they're doing that. No, it's not Fauci at all. We don't trust Fauci. We trust science, the institution of science. The patient was treated with a single dose of intravenously administered PM359. The NADPH oxidase activity was measured biochemically before dosing, and again 15 and 30 days after dosing. This revealed that treatment with 15 and 30 days. This revealed that treatment with PM359 led to complete restoration of NADPH oxide activity in 98% of neutrophils by day 15 and 66 by day 30, which is significantly higher than the anticipated minimum threshold for clinical treatment of 20%. They were aiming for 20% and they got 66%. Wow. Like that. How old was the patient? The patient was treated. Okay. Are from the first adult patient treated. Okay. Wow, that's crazy in an adult to have that kind of you'd think that less cells with the kiddo would be easier to treat, Additionally, this patient experienced rapid engraftment of his autologous transplant following myeloablative conditioning. Engraftment was confirmed in neutrophils on day 14 and platelets on 19. This is nearly 2 times faster than approved gene editing techniques, where median engraftment has been reported to occur on day 27 and 35. Yeah, exactly. This is for all people living with CGD. That means that they could be treated right now. They don't have to been treated beforehand. Yeah, you can restore the NADPH oxidase function and therefore reducing the risk of acquiring a deadly infection. Yeah. You're grateful for our first patient and his family and caretakers. That's incredible. Second, these data answer key questions about prime editors, confirming their potential to be delivered and safely restore normal gene function. This reaffirms our conviction that prime editing will be the foundation of a new class of differentiated one-time genetic therapies, and we look forward to advancing our broader pipeline of investigational programs directed towards large genetic diseases that impact the liver and the lung. Prime Medicine does not plan to independently advance its efforts in CGD. Prime Medicine is exploring options for the continued clinical development of P359 external to the company and ceasing further efforts in X-linked CGD. Wow, so they're done with that and they want to go to other things. Prime Medicine believes 359 has the potential to transform the care of that specific mutation and is committed to working with urgency to identify an appropriate partner to help ensure this. So they think that it's done. They're not even trying to go through with it. That's incredible. Do you know what other diseases might be treatable with this? Yeah, I think that they're going through that right now. Prime Medicine will continue its in vivo cystic fibrosis program. And prime edited CAR T products for hematology, immunology, and oncology. Yeah, that's incredible. That's unbelievable. They want to rapidly expand its pipeline, potentially including additional genetic diseases, immunological diseases, cancers, infectious diseases, targeting genetic risk factors in common diseases. Wow, very cool. I don't know what you mean, Doc. I don't know what England's doing in regards to pandemic simulations. I mean, they're going through a gnarly flu season. That's what's going on. They're not simulating anything. They're going through a gnarly flu season. Australia and Japan had a gnarly flu season, and now the UK is going through a gnarly flu as well. No, that doesn't make any sense. They're not practicing anything. They're practicing medicine, dude. Like, I'm sorry, but you're just not everything is a conspiracy, brother. You know? I don't need to look. I'm not, bro. We're talking about science here. We're not looking up your crazed conspiracies, okay? We're actually trying to learn right now. I know this is a just watch as people learn about subjects and understand them deeper by looking through research and scientific evidence and building knowledge about something that they don't know about, as opposed to just going down rabbit holes for crazy conspiracies that are blurted out in a alcoholic, drug-induced coma state. You know what I mean? Yeah, exactly, Barry. Exactly. Okay. Hi, how's it going?
Even my dog is barking at that guy in the comments and his conspiracy theories.
Yeah.
We don't have to stay stupid. We don't have to stay stuck on stupid. We could actually learn some junk.
Exactly.
And it's fun.
Exactly.
Just get yourself vaccinated, pour yourself a glass of Franzia, kick back and learn about science, and enjoy
Exactly.
yourself.
Exactly. There you go.
You don't have to be a rubber donkey lung. You could actually be a participant.
Exactly. Or welcome. You're welcome here to stay. Be normal. Just be normal. Cool, man. So the study started in 24. Thank you, Miss Cake. And its completion is 2030. That's incredible. So there are going to be 12 different enrollments. That's incredible, man. What's the study plan? Dude, do we know what it is? Single administration. I want to know what is it? Lipid nanoparticles? Like, how is it? What's the sequence? Like, is that, if it's patented, it should be, the sequence and stuff should be there. They should have the sequence readily available. I just want to understand better what is going on. Okay, cool. This is a paper on it. You might get better protocol details. Ooh. Ladies and gentlemen, we might have it here. This is the year in review. Nope, doesn't have it. Ooh, protocol details. We want vector maps. We want nucleotides. I'm trying to understand what they're actually giving. Are they giving protein? Are they giving RNA? What are they actually putting into the patient? They're doing something IV based, but I would assume that it would have to be protein. It's basically RNP, ribonucleic protein. So you have RNA with the guide RNA with the sequence that you want, and then protein, and then they bind together, and then that's ribonucleic protein. Tom, we are learning about human gene editing. I have a debate on Thursday, and I am trying to understand more about it. I'm curious about what the actual medicine is and what it actually is. I'm assuming it's an in vitro transcribed, ex vivo, prime edited. I think maybe looking into prime editing more. Sometimes just like their press releases might be a good idea. Here we go. See guys, so I'm talking about the non-viral nanoparticle. Prime editing can be delivered to the right place in the body using multiple modalities. So a viral vector, an RNA protein complex, that's what we were talking about with the RNP. Prime edited cell therapy. Oh, wow, this just came out. Methods for genome-wide detection of single-stranded breaks induced by gene editors reveal that specificity of Saccharomyces. No, SP is the species of Cas9 that people normally use. So there's like different flavors of it. Of SP nuclease functions and provides comprehensive list of potential off targets for prime editors. So they're looking at, so this is a poster. So a way for people to understand what scientists are going on about and what they're researching. One is publications, right? And we peer review those publications and we talk about those. And another thing that we talk about after they've been published and kind of like talking shop, how we kind of like, talk to one another, is posters. So people will print out a poster, and then they'll go to conferences, and then they'll talk to one another about like, hey, what do you think about this idea? I'm having this problem, this thing, this idea, what do you think? And then people can come up and be like, oh, this is interesting. What are you doing here? So they're talking about strategies and methods for detecting potential off targets. So they're creating a way in order to see if there was a problem in administering this medicine. Was there something else in this in the genome outside of our target region that was impacted? That's cool. So in vitro digestion, so outside the cell, genomic DNA. You have the nicking enzyme, the denaturation and Nick ligase. Oh. Oh. Oh, that's genius. This is some molecular biology stuff, but this is a really cool thing. It's all right here. So basically this right here, they're creating, how they repaired that part of the genome that David Liu was talking about? Basically, they created a way to check by denaturing the DNA from one another so that you had two pieces of DNA, and then they sequenced all the pieces of the genome. So if they don't match, then those pieces, when they sequence the genome, aren't going to align, right? There's going to be off-target effects that they can sequence and they can see. So that makes sense. Read, pile up, and analysis. Exactly. This is next generation sequencing, guys. So of course, how they check to see if there was a molecular biology nucleotide error is by sequencing. I mean, basically molecular biology comes down to the gels or sequencing, and that's part of the thing that they use. No AI has helped. They don't use AI at all. I mean, I've used, you use computer science, but you don't use AI necessarily. You're aligning millions of reads and stuff, and making sure that they align and they all have the same sequence, one on top of one another. But you don't need AI to do that. You don't want AI, because you don't want to introduce a black box. Basically, you introduce a black box on something that you're using in order to actually understand something. That's even more scary. You want your variables. You want to be the ones that you're introducing through experimentation, not from the AI. You know what I mean? Yeah. No, that's a good question, user. In the future, probably. No, the question for AI is like, how do these sequences and this analysis change over time based off of these parameters? And then it could use deep learning. So deep learning is a way that you kind of feed a bunch of information to an AI model, and then it can figure out like what is different here that you might not be looking for, and that would be a cool way. Okay. So I can't follow what's going on in the chat. I'm sorry, guys. All right. Okay. Let's see if we can watch another David Liu video. So this is a good 4 years ago. I think I listened to this. Episode 106. Oh, here we go. I saw this actually. This is made its round.
Our lab integrates chemistry and evolution to enable new kinds of medicines. The hope is that by enabling the direct correction of misspellings in our DNA that cause these grievous genetic diseases, that we can give patients and their families hope where previously they may have had no effective treatment. Ultimately, as a scientist, I think our obligation, especially since we're funded by the public, is to benefit society. We share all of our research findings with the public. Thousands of laboratories have used these tools to enhance their research and to treat patients. I worry that the current uncertainty about prioritization of science support by our government puts science in grave danger. What worries me even more than the termination of a promising line of research is the fact that students who observe that termination and understand why that science was so important are starting to conclude, this isn't the career for me. Because if science that is that directly promising can't get funded or no longer is able to continue, it doesn't give them a lot of hope that their career in science will be a fruitful one.
Let's go, David R. Liu, getting political. Let's go, dude. Let's go, David R. Liu, man. Let's go, baby. I'm telling you, dude. I'm telling you. Oh, CSHL keynote. Ooh, this is a good one to watch. 3 months ago, an hour long. Ooh. Yeah, there it is. Streptococcus bacterium. This is what Streptococcus is that's where they actually got the Cas9 protein. Yeah, exactly, Sandy. That's what he was talking about, that we are dependent on science to be funded by the public. We want it to be funded by the public, guys. That's the whole point of it. The whole point is that it's publicly funded so that we can share the research, that it can be available for all, that it can be used, to eventually, yes, a lot of these universities are spinning them out into biotechs and companies, and absolutely, it is the engine of our economy. The competition that is made by these companies are the ones that, disrupt pharmaceutical companies, for example. They try to, like David R. Liu is creating gene therapy approaches that disrupt the need for a lifetime of medicine, for these patients. It's just a single administration so that they can live their life and they can have a higher quality of life without the need to be constantly taking these medicines. It's like these are the disruptors. These are the technologies that we need in order to help.
Good morning, everyone. Great to have you all here, and we're overflowing, and that's because the meeting is very well subscribed, but I think that also has something to do with our keynote speaker today, David Liu. David, I think you all know
who he is. Imagine having to do an introduction for David R. Liu. Imagine that, dude.
Going to cover that, and of course he's going to give the keynote. But he downloaded his CV and lots of
guys. He went to my alma mater for his for high school. He's from Riverside. He was right from UC Riverside. Isn't that amazing? Effects of neural density on visual processing, a neural network model by human experiment in 1990 as a high school student. He got number 2 for that. That was a number 2 project in high school. Unbelievable, dude. I know. Dude, Heather, I did some science fair coaching and judging for these things, and I'm telling you, it hasn't changed. These people are doing basically research level publications, and a lot of them, it is kind of unfortunate because you can tell that their parents are like in the lab, or they have a lab or something, and they're basically using their parents. they're using their parents' lab, and they're going to them, right, in a, you know, like 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 summer program and then doing some research and then doing it. So, you have to think about that. It's not fair, to be honest with you, but yeah, it's fun. Guys, PhD in organic chemistry. Hey, you know what I mean? You can't hold it against him. He's not perfect. He didn't do biology. You know what I mean? Don't hold it against him. All right? He's still okay. I kid my chemists. I kid you. Thank you. I thank you. I kid. I can't believe a high schooler could even know how to do that, but that makes sense now. Yeah, you're a lot of mentorship. To get to that level that quickly takes a lot of mentorship. And that, like, genuinely, guys, if you are trying to go into a career, or you're figuring out what you need to do, or if you're wondering what's going on, find someone in that space and ask them questions. And a lot of people, especially in science, they'll help you. Genuinely, they will help you, try to mentor you into those programs. So I've done it multiple times. People have emailed me out of nowhere, and they just started asking me questions because of my fellowship or whatever, or fellowship mentees in the future. They'll see my application, and they'll use it as a template, and then ask me questions and ask me like feedback. There's a lot of people in academia that are willing to give you the time if you just ask, for sure. Heather, it happens to a lot of people. It's not just me. Yeah, exactly. Amy's doing the same thing. And it's because people know that they are only there because of other mentors. You know what I mean? You give back what you got. And I've gotten some of the best mentors in the world helping me out and helping me rise academically, professionally. And that's kind of like what I see, like I'm doing with you guys right here, with this community. And obviously my DMs on Discord are open. That's probably the best way to get a hold of me, to be honest with you. And some of you have gotten back to me and asked me questions about grad school and how to get in and what they should do. And I love that, and I appreciate that, and keep them coming. We actually have on the Discord careers. So we have a channel in there just about professional development. So if you were interested about professional development and you want to get into science, or you have questions about that, please join the Discord, go to the careers channel, ask your questions, and I can answer your questions there.
Interesting things starting from when he was in high school. And so I think it was probably very apparent to everyone from a young age that he was going to make amazing discoveries. So in high school, he graduated number 1 in this class, and he was also important.
Okay.
Kind of stood out for me was that it was Peter Schultz, clear amazing scientific achievements, but also his interest in using these for the good of humanity. Here are a couple of pictures with patients who have been very important in, I think, in your accomplishments. So Alyssa, this is actually at the breakthrough ceremony.
Wow.
She's introducing you. Was the first patient treated with base editing. She was
really
under the impression she was going to be dead very soon after getting the leukemia diagnosis and having treatment failures. But after T-cell editing, then
that's incredible.
Seems to be quite healthy and in
that's
remission.
Incredible.
And then Sami Basso.
Okay.
But in fact, David has an enormous number of outside interests, which I think he uses in this work-life balance to kind of clear his mind, to be able to think great things. And so this various aspects of art, merging art and science, photography is particularly important. And
loser.
He's very accomplished there.
The lower right
is a shadow art. He could perhaps
it looks like a PCR block. What is that?
Showing his family, his wife and his daughter. That's not all, though. I think
He has a wife and a
this
family?
seems to be pretty well known that he's elite in
Blackjack? My man.
blackjack.
Let's
the
go. Let's go, dude.
Surprised, he
It's
could
okay.
get away with this, but he had a student class
Wow.
blackjack, not as part of the official curricula, I think, but they worked very diligently on
That's incredible.
Trying to
Nice, Heather.
understand and come up with algorithms, I guess, to be able to beat the Vegas blackjack people.
Odds.
And eventually, the story is that you got banned from several
Did he?
places, the MGM,
Wow.
for example. And so
Okay.
this tree, for some reason, there isn't a picture of Sam.
What?
Him. But sometimes he is art, and this is a picture from Richard Branson's Island when Richard Branson had some think tank thing going on.
Wow.
And,
Okay. Wow.
Has a
Dude, I'm telling you, he's cool, dude. He's a cool dude.
Meeting. Thank you, Maria. I don't have much to say about the introduction other than I feel ready for my next job interview.
Mutation specific, mutation agnostic. That's the one, guys. That's the thing. I just talked about August. It only has 3,900 views, guys. Guys, this is, I'm telling you, we're like, just, you know what I mean? Who talks about this stuff? Nobody talks about this stuff. This is like a TikTok first. David R. Liu, deep dive on David R. Liu. Who's doing that? Who's doing that? Nobody. Nobody does that. Gosh, it's so cool, man. I would watch this. I would watch this stream right now. You know what I mean? I would. We are. I am too. I'm stoked. I'm happy to be here.
To this event that was held on an island that Richard Branson holds these think tank events. We were encouraged to dress up in costumes. Sam's was actually pretty remarkable. It's unfortunate he didn't volunteer a picture of his own costume. I wore this T-shirt, which you can get on Amazon inexpensively, that has a programmable digital display, and I uploaded the faces of all the other attendees into the shirt. And so we cycled. Richard was taken aback by this shirt. He loved it. He just kept talking about it. And so in the final breakfast the next morning,
there's no way, Heather.
Presented him with the T-shirt and said, you know, this is a gift for you. Thank you for hosting us. And then I added, because you've now fulfilled one of my bucket list items. I've always wanted to give the shirt off my back to a billionaire. Okay, so today I'll describe...
Nice.
Oh, sorry.
It's hilarious.
All right. So today I'll describe 3 distinct strategies for therapeutic genome editing. These strategies demonstrate how the development of gene editing technologies enable a variety of therapeutic approaches, some of which have had already a substantial clinical impact, as Maria hinted. But I think...
guys, I don't know. This might just be my algorithm. You know what I mean? I guess it's like I searched, guys, David R. Liu. I put in David R. Liu, and look at what I said. It's me. I was like, no way. This is one of my first TikToks ever. This is like my 3rd one. I was like, and I was going through, and people were like, "Oh, you should stitch like in order to like get into someone." And I was looking at some like really popular channels, and one of their latest ones was about David R. Liu, and I'm like, "No way, we're gonna watch David R. Liu is on TikTok right now. Like this is so cool." It doesn't. I don't think that he has. It doesn't look like it. That is not David R. Liu. Let's look at this geek right here. Unmute.
Alive right now. He's hacking evolution to create medical technology.
Dude, Dr. Cal Science, guys. Your Cal Science pal. And she's
the most important people alive right now.
look what she said. She said, this is one of the most important people alive right now. Okay? That's your science pal saying that. That's not just me, okay? She just said this is one of the most important people alive right now. All right? It's not just me. It's not just me.
This is one of the most important people alive right now. He's hacking evolution to create medical technology.
Dude, no way I am scrolling TikTok and I see someone talking about David Liu. He's one of my favorite scientists. He's an absolute inspiration for molecular biologists. The thing he's probably going to be known for in the future is using his evolved CRISPR tools to change single nucleotides inside the human genome so that you can precisely edit out disease and heal people and cure people from these genetic diseases. But if you love directed evolution, you got to check out Frances Arnold too. She's basically doing directed evolution with chemistry and creating new molecules and new enzymes that have never existed before in nature and more of a kind of like renewable fuel.
This is one of the most important.
What? Who is this guy? What is that? July? He looks July 12th. Wow. Wow, guys. Looks like a burgeoning TikToker that might blow up soon. We'll see. We'll have to monitor him closely. That's really funny. Of course, when you TikTok surf David Liu, I'm on there. You know what? I'm honored about that. You know what? The TikTok, the 60 minutes clip, and then me, all right there. I love that. Yeah.
I think more interestingly, they demonstrate how science advances and creative applications of the science can help address distinctly non-science but really important bottlenecks, practical, regulatory, economic challenges that are currently some of the major barriers to connecting the science of gene editing with patients. Okay, so we developed base editors and prime editors to enable the first strategy, which is installing or correcting specific mutations in living systems. These are engineered proteins that make specified changes in DNA without requiring double-stranded breaks or donor DNA templates.
See, here you go. See this? The lab evolved the deoxyadenosine deaminase. That's what we're talking about. Lab evolved, guys. He was using directed evolution in order to do this. He was using evolution as a tool in order to actually create this stuff. That's what's so cool about this too. He's not just doing it. He's doing it the coolest way. It's amazing. God, he's so cool. I love it. I'm so jealous, dude. I wanted to join his lab so bad, but it was just like impossible, you know?
And base editing and prime editing have been used by many labs around the world, including many at this meeting, to correct pathogenic mutations in cell and animal models of genetic disease. And so in new work, in collaboration with the labs of Kat Lutz and Al George, we used in vivo prime editing to rescue alternating hemiplegia of childhood, or AHC.
Hemiplegia.
This is a severe neurodevelopmental disorder that presents with paralysis, involuntary movement, and seizures. There's no effective treatment for AHC. And so we took a slightly different approach than the usual. Rather than starting with the mutation that we thought we could correct, we instead simply started with the most prevalent mutations that are known to cause this disease. And we developed base editing or prime editing strategies that correct with about 43 to 90% efficiency 5 mutations in ATP1A3 that collectively are responsible for more than 70% of AHC cases. And although 4 of the 5 mutations are transition mutations, and therefore in theory can be corrected by base editing, as bad luck would have it, we ended up choosing prime editing to correct all but one of these 4 transition mutations due to non-silent bystander edits that resulted from base editing. We then used AAV-mediated in vivo delivery of an...
AAV, so that's adenosine. AAV is a viral vector, AAV. So that's like the delivery mechanism that they were using. Interesting. So that they are using, right?
Optimized prime editing system to the central nervous system of 2 AHC mouse models, resulting in quite efficient.
Yeah, it's an adeno-associated viral vector, using a modified harmless AAV virus as a vector to deliver a therapeutic gene into a patient's cell. Exactly, adenovirus-associated virus.
And editing 30 to 50% of the bulk brain cortex, correcting these mutations, or among transduced cells, 50 to 90% correction. And correction at the mRNA level was even higher, suggesting that prime editing occurs more efficiently among cells that express ATP1A3, which likely reflects the neurotropism of AAV9, the capsid that we used. And importantly, the ATP1A3 ATPase activity of the treated animals was substantially restored in the hippocampus. And so both the prime editor injected mouse models, both of these 2 mouse models shown here, showed.
It's like, guys, it's like, it's good science isn't just the scope of what they're doing. It's not just like what they're getting done, but it's like how they're recording and showing and demonstrating they're doing the right thing. And you see a good experiment and you're just like, dang, they thought of everything. That's such a good experiment. They really rigorously and just debated this thing, just full throated, and just made sure that they got every angle, everything, and they're asking the right questions before they did the experiment. They're doing the experiments well. They have strong statistical correlations because they actually performed like the pipetting and the liquid handling right. Everything is just going into it. And you're like, dang, so good, man. A good experiment is just wow. Any good book recommendations? I just read The Selfish Gene. Okay, nice. The Ancestor's Tale, Your Inner Fish. I heard The Violinist's Thumb is like supposed to be good for like pop sci. I honestly don't read books. Sorry, I'm just being honest. I'll read audiobooks. I'll listen to audiobooks, but I do like Brandon Sanderson's books, his Twilight Archive, Stormlight Archive. Yeah. But yeah. Yeah, of course, Brittany's. Yeah. Violinist's Thumb. I've heard of that. Yeah, I've been. Yeah, I got through book 1, and then I'm working on book 2 of Stormlight right now. But I did the other one, with the Mistborn, and I love Mistborn. I thought Mistborn was so good. Twilight. Okay, sorry, it wasn't Twilight. It wasn't Twilight. Okay.
Strong rescue of a number of behavioral and cognitive deficits, including stress-induced.
Guys, the rescue. What are they talking about there? Rescuing that. So what they're doing is that they're causing a knockout event. They're causing something to turn off, all right? And then they are specifically turning something back on. They are rescuing that. So what they're showing is, hey, this thing that went through this process, was it harmed? How do you know it's not harmed? If it wasn't harmed, then restore the gene that you just knocked out. Show me that gene has been restored. And then if just that one gene was knocked out and you restored that one gene, what would you see? If you knocked something out and made it not operable, and then came in and restored it and created, put in the original copy of that gene, your hypothesis would be that it goes back to normal, right? If you restore the wild type sequence and the original sequence, and something happens where the function isn't the same as the original wild type, then that means that you did something wrong, right? The off-target effects was too bad, or the transformation, the ability for this organism to kind of uptake this DNA, it was too, it was too hard for the organism to go through something, and actually it hindered it going forward. So you have to show in molecular biology that you're knocking something out, and then you have to restore that. You have to bring back the original sequence, and you have to show that they're the same.
Seizures shown here, as well as movement, cognition defects, and importantly and somewhat dramatically, extension of animal lifespan.
Wow.
And so this type of work suggests the feasibility of using prime editing as a potential one-time treatment.
Dude, 52-week mouse study? A year? That thing lasted a year. Wow, so not only was it restored, but they're actually like staying and living for a very long time, as long as the wild type. That's incredible.
For AHC, and maybe more importantly, represents, to our knowledge, the first use of prime editing to rescue a neurological disease in animals. And so we're currently...
Oh, there you go. Who asked about it? Neurological disease and anything neuro. Oh, thank you, Lo. Yeah, I was a microbiology professor for a quarter at UCR. I was a adjunct professor, and yeah, it was fun. It was fun. It's hard. It's a lot different than this. This is a lot different, but thank you. I appreciate you saying that genuinely.
Working with Rare Hope.
We should, honestly, it would be fun. You know what? We'll go for when we do something. It'll be some event or something. We'll go through my old teacher evaluations, all my professor evaluations, except for San Diego is better. Okay, sure.
Scientists at NIH and elsewhere, as well as companies who are generously contributing their expertise to try to move these results towards a clinical trial. And therapeutic editing results such as these, along with the contributions of many other labs described in at least 2,500 base editing and prime editing.
This is, guys, like, one of the best gifts, one of the best compliments for a scientist is to have their work reproduced everywhere. What it means there is that not only is it reproducible, but it's easily done. It's easily reproduced. Sometimes you have a really complicated thing that can be really hard to reproduce, and you literally only have a couple people in the world that know how to do it right. You can be, the right things all come together, and you can reproduce it with the right hands in the right spot, with the right cells in the right lab, and like nowhere else. Genuinely. Sometimes that happens. Sometimes a graduate student graduates their PhD, they go on to be a professor, and they just can't bring that tool forward with them because they can't reproduce it again for whatever reason. Sometimes that happens. So the idea that we're looking at all these candidates across all these labs, across all the world. So not only is it reproducible, but it's easily reproduced. And so lots of people are able to do this. This is like, guys, this is, it's unbelievable. It's genuinely, you can't, it's amazing. It is amazing.
In publications to date have resulted in at least 23 clinical trials using base editors or prime editors to treat a wide range of diseases, both ex vivo.
How do you explain the reproducibility crisis in science today? So, Jason, it's kind of overblown. Basically, what the reproducibility crisis is it's not people going through and trying to reproduce everything in science, and it can't be reproduced. What it is, and where the reproducibility crisis came from, it was a paper like 20 years ago now. What they did was that they went through and read the methods sections of papers. And what they found was that the methods and the procedures that are explained today in those papers were insufficient in order to reproduce the study. So they found huge glaring holes. They weren't able to actually have like all of the parts in order to reproduce it. And then therefore it was deemed not reproducible. So, and then they went through a bunch of different fields and they found that like biomedical science and stuff like that had the highest not And then you had like psychology, which was the lowest. And you had, the file drawer problem. I'm not familiar. So the idea was that like psychology was doing not a lot in order to make it reproducible, but medical science and it makes sense. Medical science has to have a lot of details. So you kind of have to put everything out there. But when you are doing a publication and you are writing a publication, I mean, it's hard to put everything in there. You can't put your lab notebook up there. You know what I mean? It's hard. So and a lot of times, if your paper is good enough, what'll happen was they'll actually ask you to do a protocols paper. So like Nature is a good one on this. Like Nature, you publish in Nature Medicine, and then they ask you to do a Nature protocols paper afterwards in order to do it. Studies when hypotheses is not supported end up in the file drawer. Oh, okay, yeah. So the ones that get published, the p-value is meaningless. So basically the problem is that you have to have a positive claim. So I've seen one paper it's interesting. I thought that this was a bigger problem than it was personally. Like I thought this was a huge problem before I became a scientist and like published and stuff. The problem is like, okay, the paper was this organism couldn't be transformed. And being able to be transformed, which means that they had DNA incorporated into the genome, this is a very hard feat, actually. So a lot of researchers spend like their entire career trying to transform an organism, for example. This grad student, it was probably a grad student that needed to graduate. They had probably spent their entire PhD trying to transform this thing and couldn't do it. So what they do, they listed out all the different ways that they transformed this thing. All the DNA, they did their the strains, the methods that they did, what failed, what didn't fail, what positive controls they used, what was the negative controls that they used. And I was reading the paper, and it was interesting. It was genuinely, I think it was in PLOS One, so it was like a legitimate journal too. And it's like, okay, so I'm reading this. And it's like the first negative results paper that I ever saw. And I'm like, yeah, but like, this is nice, but what if you just didn't have a start codon in your DNA sequence or something? What if you like just didn't refrigerate your materials and your nutrients or something basically went down and you didn't have it in order to transform, and then you didn't have like a simple thing. You know what I mean? Like there could be something in your procedure that you haven't encaptured with the part of the process that you aren't saying in the paper that you failed to do. And that's the problem, is that you can in good faith be trying to say everything that you can, but have something that you looked over, that you looked past, and you're just like, oh my gosh, how do we do that? That's insane. This happens all the time with dissertations, by the way. A lot of times people will just like really quickly put out their title, and they'll have to put the whole Latin name of the organism. Like, for example, Chlamydomonas ranhardi. Ranhardi is actually spelled a couple of different ways, whether or not you have the H in there, whether or not you have the HARDTII, whether or not you have the T or the D. It's like there's just different things. But you can have a lot of times people have misspellings in the title of their thesis. Imagine that. You work 7 years in a PhD and you've worked on this organism for this long. You've loved this thing. You're doing everything that you can, but you're just scanning over that word for so long that it's just normalized in your brain that you don't like think about it, and you You just see that. So that could happen with your experiments, basically. It's like, oh, I didn't know that we were supposed to refrigerate our micronutrients. And people said that this was okay. I didn't know that it was expired. And it's like, well, yeah, so that therefore everything else that you touch, you could be in good faith, like reporting on all the things that you did, but like if you just didn't do the right thing, how do I know what to do? So that's kind of the problem, man. And like I was reading this paper and I'm like, this is cool. This is like exactly what I've always wanted to see, but I'm also understanding why this is such a bad thing to publish, because you actually have to have a positive thing. You have to have a positive result that you're saying that you did in order to show that you did something. You know, like there's a lot of different ways to not do something. Does that make sense? That there's only one right way to do the thing that gave you that result, and you need to tell us, what did you do? What did you do? Do you know what I mean? Does that make any sense? It's kind of a weird thing. I didn't understand it until I was a published author myself, and kind of like looking through this, and I read that paper, and it was actually a really illuminating thing for me. And it kind of makes sense why we don't publish negative results to me anymore. Right, but the real question is, if the experiments prove unsuccessful, do you still publish them? Brittany, you do not. You do not. You change your hypothesis to actually encompass a positive result that you can actually report on, and you can actually say that you did. Especially with complex overlapping procedures, it's so easy to get them out of order. Yeah, or just not do them in the wrong order. Do something before. This is actually a big thing. Quang Ming, this is actually a really interesting point. So for my nanoparticle stuff, for my nanotechnology, in order to create my single-walled carbon nanotubes, I had to sonicate them, which is sonicating heated up the mixture and made it so the polyethylenamine would like coat the carbon nanotubes, right? And then the idea was to use centrifugation in order to take those clumps out of the single suspension of the carbon nanotubes with polyethylenamine. And basically, do you sonicate first or do you centrifuge first? And that was like, we didn't know. This is like 2 years of my life where I am trying to test these different things. I'm like, do we sonicate first or do we centrifuge first? And everyone's like, well, I don't know. I'm like, they're like, oh, does it matter? And I'm like, I think it has to matter. What are you talking about? What do you mean? It's like one of them is like centrifuging a bunch of this stuff out, but maybe if there is clumps in it, maybe I sonicate them and I disperse them. So then maybe it's okay that I have the clumps in there. Exactly. No, Sequang, that's the thing, is that you have so many carbon nanotubes that you could centrifuge first, get the clumps out, and then you could better coat the single-walled carbon nanotubes that are already suspended in the suspension. Exactly, Quang. This is what I'm saying, dude. This is what I'm saying. And I'm like emailing back and forth these other labs, and they're just like, and I'm like, what? This is insane to me. So anyway. We did the sonication first and then the centrifugation for all my stuff. That was one of the things that I did, was like making a reproducible procedure for this thing. Oh my God. I needed a procedure, guys. It took me 2 years of chemical engineering in order to do this. It's like, it was a lot of work, man. It was a lot of work. But if I didn't do anything and I didn't work, then my project didn't work. What am I reporting? And that's the thing, is that my initial aim of my thesis we didn't do what we were supposed to be doing. So then you have like off ramps, you have exit ramps where you can be like, okay, so we didn't do this thing, but like we got 3/4 of the way there. And then now what can we actually show here with this 3/4 of the way? You know what I mean? So there is a lot of, there are ways, like again, this is, we don't publish negative results problem is largely, I mean, no offense, but it's largely, it's from people that haven't done PhD level research, and they don't understand publications, and they don't understand hypothesis driven research. And that's okay. It's a good question to have, and I'm happy to answer it. But it's like, I'm telling you that going into it, this was like one of the things that I was really cared about. I was like, I want to publish my lab notebook. I want to publish every result. I want to publish everything. And it's like, at some point, you actually just want to tell people, what did you actually do? What were you actually able to accomplish? And that is actually the most important thing going forward that people can take the most. Your failures and what you didn't do or what you couldn't do is kind of anathema. It's like, it's actually not that important, if that makes sense. It takes time. It does take time. Did you get a patent for this? Yeah, I did. We did. Yeah, we did a nanoparticle delivery to the chloroplast patent. Yeah, that I'm on. But yeah. So it's tough, guys. It's tough. Scientists, the nobody publishes negative results, and that's a bad thing for science. Is like, if it was good for scientists, they would publish it. It would be in their self-interest in order to publish it as well, you know? He said, mycology is for fun. Mycology is a good time. Yeah, exactly, Call Me Bob. Yeah, the whole point is to do a thing that actually works and to answer a question. Yeah, exactly. And then my mycelium stopped growing, and it took me 3 months to realize I was using chlorinated water. See, dude, stuff like that. Exactly. You're like, you don't know my company, dude. Yes, exactly, Amy Cook. Everything takes forever. We can't spend it on things that don't work. Yeah, exactly. I don't know what you mean, Davy boy. I used to do well water for the last 30 years. I've had my wells until recently. See, Quang, that's legitimately. Hey, Mitch, what's up, dude? Quang, that's so crazy, dude. Like, so we had our soil plants. So we had like Arabidopsis plants, and like tons of transformations, tons of experiments not working for months. People were like, what happened? Like, what in the world happened in order for us to get all these negative results? Like, did we change the nanotubes? Did we change the parts of the experimental procedure? What are we doing right? What are we doing wrong? And guess what? The provider of the soil changed. So the way that at UCR we got our soil delivered, and basically the people changed an autoclave setting on our soil somehow, or something happened like that, and it was basically the soil was being delivered to us in a different way, in a different scenario, and it was causing these huge scenarios, these huge downstream effects that were awful for us. And it's like, imagine us publishing that and being like, here is all the things that we did and we tried, and all the different types of carbon nanotubes and the different types of kits and the different types of reagents, and this is what it is. And it's like, it was just the soil. It was just the soil, it was a bad lot of soil. That was it. You know what I mean? That's not captured in that publication. You know what I mean? It's actually a great example. Are you grow up? I don't understand what you mean. Yeah, there's tons of challenges, especially when you're pioneering a new field, or you're pioneering in a new space. It's incredibly frustrating, guys. It's incredibly frustrating. It's almost like going into a room and you have none of your senses, and you have no sight, no touch, no smell, no taste, nothing, and you have to do a GeoGuessr. You know what I mean? You have to figure out where you are in the world, and you're like, how could I even do this? How could I even possibly tackle this? And then it's just about finding walls. It's about finding walls, like maybe I can figure out where I am it's incredibly frustrating, guys. There's so many variables that you have to try and use. It's really, really tough. Mitch, we're looking at human genome editing. We are looking at David R. Liu's lecture at what he just did a keynote on 3 months ago, and he's talking about all the base and prime editing that he has, and he's a legend. He's an absolute living legend of a scientist.
Vivo and in vivo. These include blood disorders, heart disease, metabolic disease, amyloid disorders, muscular dystrophy, and more. And so it's really a humbling opportunity to highlight some of the amazing clinical work of scientists and clinicians around the world using these technologies. As Maria already mentioned, Alyssa Tapley, this then 13-year-old girl in the UK with T-cell leukemia, is and always will be the first patient treated with a base-edited therapeutic.
Legend.
In 2022, she was infused with CAR T-cells containing 3 base edits in a clinical trial led by Wasim Qasim's lab. And following treatment with these triply base-edited CAR T-cells, her T-cell leukemia went into complete remission.
Wow.
And now, more than 3 years after treatment, her cancer remains undetected.
That's unbelievable, guys. That is so incredible. Her chemotherapy and bone marrow transplant had failed. Wow. That is unbelievable. Complete remission by 1 month. Wow. That is so cool. Soil for what experiment? For Arabidopsis experiments. Arabidopsis thaliana is a land plant.
She's back in school, and she hopes to pursue a career in biomedicine.
Dude, yes. For real. Can you imagine? She's doing experiments with prime editing, trying to help people at the same. I mean, that is what an incredible story, man. Wow.
In late 2023, clinical trials results were announced from the first in vivo base editing trial. This is a collaboration with Verve Therapeutics and Beam Therapeutics involving, among other people, one of the co-organizers of this meeting, Kiran Musunuru.
So this
Patients
is
with
in vivo base editing. So this means that in vivo they are creating it. So that's why they're talking about here with the mRNA via LNP. That's mRNA, just like the COVID. They're basically doing the COVID vaccine. This is them delivering the mRNA and lipid nanoparticle together. So before they were using proteins, RNPs, and now they're delivering it in. They're creating the tools inside the body. I wonder why they're using one versus the other. It must be like a specificity thing. They're trying to go into specific cells and only express them into specific cells. That's what I would assume.
High levels of LDL cholesterol were given a single injection of an adenine base editor LNP complex programmed to precisely disable.
Were funds cut to research this? Yes. Yeah. This is exactly what people are cut. Like this specific slide. Yeah.
A splice site in PCSK9 with the result that their LDL cholesterol levels were durably lowered by about up to, at the high dose, about 59%. This clinical outcome demonstrates the potential of in vivo base editing both to treat a serious disease, but I think even more interestingly to lower future disease risk. In this case, by
wow, Kwang, you were studying polymorphisms and got PNS. Wow, that's incredible, man. Wow, I hope you're okay.
Introducing a precise single nucleotide substitution, single base pair substitution into a wild type gene that we all have. In March of this year, one of these clinical trials achieved a milestone in medicine, the first correction of a pathogen.
Wow, dude, Kwang, that's incredible, man. Wow. That's amazing.
Mutation in a patient. This is work led by scientists at Beam Therapeutics. They used an LNP-delivered adenine base editor to correct the most common cause of alpha-1 antitrypsin deficiency. This is a severe lung and liver disease.
You said LNP delivery, so again, lipid nanoparticle, right? That's what they're talking about, lipid, the nanoparticle. So it's like the nucleotide with the all the phospholipids around it.
That affects about 100,000 people in the U.S. alone. And as many of you saw this past May, a team led by Kieran and Rebecca Ahrens-Nicholas, who is speaking later at this meeting, so you can hear all about this story,
Wow. Look at that baby
achieved another
smile.
medical milestone, the first use of a bespoke gene editing therapy to treat a mutation found in a single patient. So baby KJ Muldoon suffered from a urea cycle disorder caused by a compound heterozygous mutations in CPS1. This is a very severe disease and a time-sensitive one. And so in a remarkable testament to, I think, both the dedication of the team and the decision-making of the team and regulators, as well as, importantly, the robustness of the underlying science.
Exactly.
An adenine base editor was developed in about 6 months and dosed less than 7 months after diagnosis.
That's incredible, guys. They generated the patient-specific cell and mouse model. So that means that they took the sequencing, put the mutations in the correct mutations into cells, human cells, and then they made the mutations inside a mouse. And then they developed the correction for the mutation inside of the actual tool. And then they tested those base pair editors inside that cell in mice, and then they analyzed within those the off target of editing, so that they made sure that they couldn't make any mistakes, and then they assessed the toxicology of those things to make sure that they got the dosage right, and then they manufactured that medicine in order for that LNP complex to deliver the medicine. That's in less than 7 months from the diagnosis. That is crazy fast, guys. That's unbelievable. That just goes to show how turnkey this stuff is, that they had got it all down and it was so reproducible. This is exactly what we're talking about, how reproducible and how incredible that is. This is what we're talking about, man. Yeah, exactly. It's so unprecedented. I've never heard about less than 7 months.
This is a process that I would normally associate with maybe 7 years rather than 7 months from mutation to treatment. And the result is that baby KJ is now doing well. And again, we'll hear more about this remarkable case from Rebecca.
Wow. So cool.
FDA recently cleared the first clinical trial of a prime editing therapeutic, in this case only 4.5 years after we published the first prime editing paper in late 2019. So this is work done by scientists at Prime Medicine. They developed an ex vivo prime editing treatment for chronic granulomatous disease. This is a debilitating and lifespan shortening primary immunodeficiency caused by mutations in NADPH oxidase genes. And so a prime editing system that corrects one of the most common mutations that causes CGD, which is this 2 base pair deletion, this loss of GT, resulted in very efficient editing and engraftment in mice of long-term hematopoietic stem cells from CGD patients. The treatment restored NADPH oxidase activity in cells derived from the edited stem cells, and a whole slew of genome-wide, transcriptome-wide, and targeted amplicon assays collectively uncovered no detected off-target edits, consistent with the inherent resistance of the prime editing mechanism to edit at off-target sites. And then this trial has very recently led to clinical results from the first 2 patients treated with a prime-edited therapeutic. So hematopoietic stem cells from 2 CGD patients, one of which is shown here, were very efficiently prime-edited, about 60 to 90% editing efficiency, ex vivo, and then transplanted back into the patients, autologous bone marrow transplant. The engraftment was very rapid, suggesting that the edited cells were not left in any kind of compromised state. And the neutrophils that repopulated the patient's bone marrow in both cases showed about 60 to 80% restoration of NADPH oxidase activity, far higher than the threshold of about 20% needed to ameliorate and restore immune system function.
Wow.
Okay, so targeting specific mutations with therapeutic gene editing is already having an impact both ex vivo and in vivo in patients that were suffering from a variety of serious disorders. A major challenge for genetic medicine, however, is the allelic diversity of most genetic diseases, many of which are caused by hundreds of different mutations in the same gene.
Exactly. So, because there's just not all mutations are the same, guys. You know, you can have, you know, mutation that make changes of the amino acid or the ones that don't. And if it doesn't change the amino acid, those are called silent mutations. So you can have, you know, some that change, some that create a stop codon out of nowhere. So if you have multiple types and multiple different rounds and multiple different spots on the gene, and you can have multiple copies of that gene, you know, in your genome. Different you know, locus is like the address of your gene, and you can have multiple. You know, it's a super important gene, or different ones have different promoters, or there's a whole different reason why. But to make copies, to make changes to all of those is very tough. So what he's talking about is just the ways that, and the number of mutations here that can cause a specific disease, and trying to open it up, right? Trying to open it so that it can be used in order to treat these diseases with multiple mutations.
Until a dramatic regulatory streamlining occurs, which I believe is underway. But
that's another thing, regulations, right? So each of these medicines with a specific sequence is going to have their own regulatory pathway, which is what he's talking about there, which is, as we saw with like SARS-CoV-2, the COVID vaccines. You know, the different sequences, they had to be used for emergency use authorization, but, you know, subsequent ones didn't, so.
It will take time. It's difficult to imagine developing hundreds of different gene editing drugs needed to treat the vast majority of patients that suffer from a disease like Stargardt's disease or cystic fibrosis that are caused by so many different mutations. Now, in the meantime, introducing a healthy copy of a gene into cells, this is a decades-old idea, might benefit any patient suffering from a loss-of-function genetic disease, regardless of that patient's mutation. And ideally, we would like to do so, which I think is the more modern twist on the classic idea of gene complementation therapy. Ideally, we'd like to be able to integrate gene-sized DNA at an endogenous genomic site, or perhaps at a safe harbor locus of our choosing, ideally in a way that could preserve some of the regulatory context or all of the regulatory context of the mutated gene, and ideally without introducing unwanted changes in the genome. So one approach to achieving the goal of targeted gene-sized integration in mammalian cells is a way to perhaps achieve allele agnostic therapeutic editing, is to use prime editing to install a recombinase landing site. We heard about recombinases last night in a beautiful talk. And then integrate using BXB1 recombinase, or even better, a laboratory evolved version that's more efficient, to integrate a cargo gene into the prime edited site. And so earlier this year, we reported the use of this approach, which we called PASSAGE back in the original report in 2022. But using the evolved recombinase, we use this.
Cool, man. Cool. Sweet, guys. Guess what? We might be getting a okay. Ooh. Looks like we might be able to have a debate on modern day debates, guys. It's like the biggest YouTube debate platform on YouTube, man. That's incredible. Let's go. Let's go. Now I have you in stereo. Are you supposed to? Are you on YouTube? Cool, guys. That's amazing. It's happening. Oh my gosh. This is ridiculous. Okay, sorry.
Approach to efficiently
Yeah,
install
guys.
cDNAs into therapeutically relevant genomic sites in human and mouse cells. And in collaboration with Sam Sternberg's lab, in work that we just published in May, we also developed a second solution to programmable mammalian cell targeted gene integration, again combining protein engineering and laboratory evolution. So in this case, we used phage-assisted continuous evolution to evolve CRISPR.
Phage-assisted continuous evolution. Guys, again, this is using viruses. This is, I'm telling you, this is another one of those, like, he could get a Nobel Prize just for this. He's just sprinkling this on. He's just sprinkling this on. Phage-assisted directed evolution. He's using viruses in order to create more genetic diversity in a gene pool, and then using directed evolution to figure out which mutation is the best. He's so good, man. He helped pioneer this. It's an approach that helps do this. You know, it's just incredible, man.
Associated transposases, first pioneered in Sam's lab for this type of CRISPR-associated transposase, but that, as they're found in nature, show almost no activity in mammalian cells. And so after evolving these enzymes using PACE, we could achieve reasonably efficient targeted gene integration of therapeutically relevant genes into their native genomic loci with minimal byproducts in mammalian cells. And as you can see in these bar graphs, the wild-type CRISPR-associated transposases show almost no activity in mammalian cells. Okay, so that's pretty much all just an introduction. For the rest of this talk, I'd like to present a third therapeutic genome editing strategy that's
Oh my gosh, guys, we might actually get, this is crazy. This is amazing. He's talking about the thing that we're thirsting over. This is the mutation agnostic part. Is he actually going to reveal this? Is he actually going to talk about this stuff right now? I'm shocked. Because he's been teasing it all year.
really designed to maximize the applicability to as many patients as possible by enabling a single composition of matter to rescue multiple unrelated genetic diseases. Such an approach, in principle, could help directly address one of the most daunting bottlenecks separating all of this science of therapeutic gene editing from patients. The fact that most of the 400 million or so patients that suffer from genetic diseases have very rare mutations that, under the current regulatory and reimbursement system, make it very difficult to cover the costs needed to develop so many different medicines. So we call this concept disease agnostic therapeutic editing. It sounds a little bit crazy. It perhaps evokes a certain South Park episode that proposed a daring, visionary business plan lacking just one small unknown. So I'm really grateful to our lab's own underpants gnomes, Sarah, Stephen, and Kita, who
Legends,
who led this effort. Okay, so premature stop codons are a cause of about 1/3 of genetic diseases, and about
premature stop codons is basically the stop codon to say, hey, this is the edge here. This is the end. Don't transcribe any further. And it's too far. It's too far. It's upstream. It's too quick. So basically, like the finish, the checkered flag is like halfway through the lap, and you can't finish the lap. So then it's bad. Elder-Strand syndrome, and I can't even afford to do the genetic. Oh, I'm sorry to hear about that. Do you think there's a way to make genetic testing more available? It should have gotten more cheap. Like it's like $1,000 now for full genome sequencing. I think it's less now because they're using microarrays, but I'm not 100% sure. I'm sorry about that. I don't know.
1/4 of all known pathogenic alleles are nonsense mutations. Suppressor tRNAs have been studied and known for decades. They have an anticodon that complements one of the 3 stop codons, and they can, of course, rescue nonsense mutations. But suppressor tRNAs have proven challenging to develop into medicines despite a number of efforts because of the need to provide them for the lifetime of the patient, as well as their typically modest potency that generally requires overexpression, which itself can cause other challenges. That said, suppressor tRNAs are generally well tolerated in eukaryotes, especially when not highly overexpressed for a variety of reasons. Cells evolved multiple safeguards to distinguish premature stop codons from natural stop codons and to minimize read-through of natural stop codons. First, the representation statistically of premature versus natural stop codons differ. For example, TAG is the most common premature stop codon, but the least common natural termination codon. Second, natural stop codons are often found in clusters of multiple redundant stop codons, all of which have to be suppressed to lead to read-through of a natural termination site. Third, there are release factors like ERF3 that terminate translation and can outcompete suppressor tRNAs at natural stop.
All right, guys. Well, we are halfway through. I want to be mindful of the time. It is amazing. David Liu is incredible. I'm so happy that we are going over him and his incredible medicine that he's developing, guys. This is so cool. Very cool. It is, unfortunately, the modern day debates is during the time of my family vacation every year. We go vacation between Christmas and New Year's. So unfortunately, that's not going to be, we're going to do it next year. But we shall do it. Okay, guys. Well, let's do, you guys want to do some GeoGuessr? What are you thinking? Yeah, nice. All right, let's do it. M8BQP. M8Q. M8BQP. Thank you, Efon. M8BQP. Dioxin does not break down very easily. Yeah, the PFAS, the forever chemicals. We're going to have a really big problem in this country due to deregulation of pesticides. Yeah, the PFAS stuff is a little weird. Problem is I don't really trust them in order to make a call on it. They're not really a trustworthy source. M8BQP. Oh, interesting. Yeah. All right, guys. M8BQP. Oh, wow. Dang, this cake. Anyone else coming? Anyone else want to come? Last call. In 5. Oh, okay, cool, Juliana. Cool. All good. Okay, here we go. Engage to. Okay, here we go. In 3, 2, 1. Not seeing anything so far. Trees, South America, I'm feeling. Oh, wild animals. Like Australia? Huh. This could be Australia. They don't have the long license plates. Oh. Reducida la velocidad. So Spanish. No. Oh my gosh, it was a service guide, but it didn't have. I'm thinking Spain. I don't know if this is equatorial. I want to say it's of Chile or Peru. Lima. I don't think it's not hilly enough to be. I don't know. That's what I'm thinking. Peru. Dang, not even close. Wow, Panama. Wow, dude. The plants were not. I don't know why, but I didn't feel like that was. Oh, thank you, F1. I don't feel like that was crazy. Next one. Man, I really thought that it was not equatorial there. Okay. Ooh. This. What kind of trucks are those? Kent Fire and Rescue. Okay, Kent. Is it not Aussie? It has to be Aussie. I think it is. Kent. Could have sworn it was Australian. Gregory. Nice. $40. There's no way it's over there. I think it's like more center here. I don't see it. It's looking for Kent. What? London? They were what? I could have sworn they were on the wrong. I was on the wrong. I got a 0. Snowy Mirage. Where did you go? Did you go? Were we both? Oh my gosh, you're in New Zealand. Oh, that's hilarious. Look at that. Look at that. That's so funny. That's crazy that we both got 0. Okay. Okay. This feels, I see, like, this feels equatorial. Like all the different types of plants. I don't think we're gonna have Rio Chico Jardín. Is that? Spanish for sure, right? No. Rio Chico is like, keeps saying Rio Chico everywhere. Where's Rio Chico? Where is Rio Chico? Is that like Rio de Janeiro? Like, is that? Okay, that's not going to be over here. I don't think. Oh man, I want to say it's South America too, but I don't know. It looks Spanish. I don't think it's going to be here again. I don't think it's Rio. I don't think Chico or Rio Chico is the right thing. I think I'm completely off again. Not my night. No way. They had Panama again? Panama again, dude? Are you serious? What? Damn, dude, this is impossible tonight. They did 2 Panamas? Are you serious? Oh my gosh, this is gonna be Panama again. Is this gonna be Panama? I should just like go Panama and go to bed. What is this? This looks like more green and lush than the other 2, which are equatorial. Okay, this. Okay, I don't know. Oh, come on. They're gonna blur it? How are they gonna blur it? Okay. Cañón El Arenal. Okay. It's a oh man. It's not my night. Las Grasas. EMAAR. Dude, I see now this, I'm going to go equatorial. Is this in Ecuador? I'm just going to go Ecuador. Because I just thought it was equatorial. It just feels like that. I'll take it. I'll take it. Okay. Yeah, dude. It's like, seriously, Central and South America tour tonight. Puerto Rico. That's like, yeah, there isn't like many Puerto Rico islands and stuff. Oh, this looks very. God, what is that? The Z? Is this Finland? Finnish? What's it say at the top there? I can't see it for anything. What? Huh. Okay. I don't know if this is the right way to go. Okay, okay. Ooh, 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 ooh. Oh, come on. I guess I'm like, is this is this Europe or is it like, yeah, it looks Europe. Buja? I'm gonna say it's like Poland or Sweden, something like that. Croatia? Slovenia, of course. Dang, I got just absolutely stomped, dude. Dang, good job, Snowy Mirage. Good work. I got absolutely busted up. That's crazy. We both got 0 on round 2. Dude, good job. On round 5, round 3, solid work. Very nice. Very nice. Whoops. All right, guys. All right. Well, that was it. That is it, ladies and gentlemen. Thank you so much for coming. I appreciate you. Let's go for our shout outs tonight. Thank you guys so much. The Patreons, guys, it means so much to me. Thank you so much. Thank you to our... Okay, here we go. Here we go. I wanted to take this and then this. Top likers. This. This. Boom. That, and then top gifts. This. Here. No, this. This. All right. There we go. All right, guys. Thank you guys so much to the top. Thank you guys to the Patreons. Brian F., Helen. Thank you guys so much. I really appreciate you. Thank you to the super fans as well. I really appreciate you guys too. The other Patreons, Mrs. Dr. G, Russell Bowden, Ado, Call Me Ness, Rapture, MB Human, Meg, Dave M. Thank you guys so much. Huge thank you for the top gifters, Miss Cake, Heather Things, Helen, the top likers, Share, Bare Necessity, User 8007. Thank you guys so much. I really appreciate you guys. And that's it. Big day for Mava. We are official. We are official, guys. We got the stuff. California said we're good. We got it. We did it. I'm probably going to go to bed. Thank you, Tiff, though. I appreciate you. All right, guys. I'm headed out. Thank you guys so much. Peace. Thanks, Heather. Thank you, guys. Thank you, guys. Have a good one. Peace. YouTube chat. Love you guys. Love YouTube. Thank you guys so much. Appreciate you, YouTubers. Thank you so much.